We want to continue with the lesson. We said that to teach the concept of energy to our students, we need to consider the concept math that we saw. We saw that we could split energy itself into sources of energy, forms of energy, the conservation of energy, and also other subtopics that we mentioned. In the second half of this lecture, I want to look at how to teach the concept of forms of energy to our students, and then we come in with the energy conservation of energy, and also the transformation of energy. So as a teacher, advanced preparation is always the key. Once you have your TLMs, and you know the prior knowledge of your students, the rest actually becomes a normal routine exercise that you always do, because your TLMs will talk for you, and if you add best practices, you will be able to accomplish your objectives for the day. And so on your slide, you see forms of energy, and you could ask students to tell you the benefits of the sun. This, I'm sure some of the students will tell you, we get heat from the sun, we get light from the sun, and so on and so forth. This will then help you to get students to understand that these things are obtained from the sun, and they are convenient to use and can also be easily transported to wherever you want to send them. So, as a definition, one would want to define the form of energy as energy obtained from the various sources that are portable and also convenient to use. From these, students will now come up with various other sources, forms of energy. So heat, light, sound, magnetic, chemical, electric, potential, kinetic, and electromagnetic energies are all forms of energy which can be obtained from various sources of energy that we have mentioned. Now, it will be your duty to convince. I said the word is persuade. You persuade through factual activities to get your students to be convinced of why you think that heat is a form of energy, light is a form of energy, sound is a form of energy, magnetic, chemical, and others that we have mentioned. So you need to do these activities. You can demonstrate that dry cells contain energy, in which case you are trying to look at chemical energy. Similarly, you can demonstrate that lemons or lime contain energy. This is also chemical. Demonstrate that magnets contain energy, or they can do work. We demonstrate that elastic bands and spring contain energy. For instance, if you take a catapult can easily kill a bird once you put a stone in it. It should also demonstrate that electricity is a form of energy. So when you take your students through these activities, they would get the concepts of forms of energy. We will look at how to do that for dry cells. What it means is that you should get dry cells. Also, you may need a lamp or a bulb, and probably you also need some conducting wires. And you make this type of connection, a circuit, with the cell or the battery. It is a battery, 9-volt battery. The wires connect them to a switch. You have a bulb, and when you turn on the switch, the light will then show, telling you that the cell has delivered some energy to the bulb. And so that demonstrates the fact that dry cells contain energy, or batteries contain energy. You could also go through this exercise, but usually it is not easy to get your lime giving you light at once, which means that to do this you have to read a lot, get enough information on the internet so that you know how to do this connection. Usually you need two different metals. Okay, so for instance, you could use zinc and copper, or zinc and other, metals like aluminium and so on and so forth. And so these two different metals, one inserted into the lime or the lemon and connected to the bulb, depending on the potential that is generated, you would have the bulb giving you light. And that also demonstrates that chemical energy is a form of energy, because the lime contains chemical, which is acid, as we all know. This is also an experiment to demonstrate that magnets contain energy, or they can do work. And so you realize that when you have some nails and you bring a magnet close to these nails, the nails get attracted to the magnet. Please remember that not all nails are magnetic substances. And so we are talking about maybe iron nails or steel nails, which are magnetic in nature. Then this experiment is possible. You can do it to other metals that are attracted to magnets as well. And this would get students to understand that magnets contain energy, or they have the ability to do work. We may also do an illustration on the use of catapults, springs, and even bow and arrow to explain kinetic and potential energy, which as mechanical energy in the last lecture, to demonstrate or to show that these are other forms of energy. So you see the catapult, There's a stone down there. Once you put the stone in the catapult and stretch the catapult, the elastic, then any bird perching somewhere comfortably, you can be assured that that bird can become a delicacy in your house. The spring can equally do same. Bow and arrows can do same. And this is how we demonstrate potential and kinetic energies. Electricity is all over. Students use electricity to charge their phones. They use electricity to watch television and so many other uses that we can think of. So to be able to get students to come to terms with the fact that electricity is a form of energy, you need to go through these activities. First, let students tell you how electricity is used. So what are the uses of electricity? You ask this question and students will be able to tell you a number of them. Then you ask them how the electricity or electric energy becomes a form of energy. See, we are saying that energy is the ability to do work. You can get electrocuted once you get close to a live wire or a high voltage cable. So all these things are some pieces of evidence to show that electricity is a form of energy and has the ability to do work. Now, also try to get students to understand that electricity can be obtained from all the sources of energy that we have mentioned. This is very important because, you see, we depend largely on electricity for our day-to-day activities. And so if children or students are aware of how we can obtain electricity from the lime or lemon, from a chemical like acid, because we would need two separate metals, anode and a cathode sort of, and then also the use of maybe the sun as solar energy, then they will appreciate why we need the concept of electrical energy. So you could put up a dialogue box like this, trying to get students to list some sources of electrical energy. And guide students to state the source from which the various forms of energy are obtained. In the second lecture, we saw that once we list the forms of energy, we should also be able to tell where those forms are obtained. For instance, we know that the sun is a source of energy, but we could obtain light and heat from the sun. We could also obtain electromagnetic energy from the sun. And then maybe we talk about solar on the lighter note. So any form of energy a student mentions, he or she should be able to link that to its source. And this is very, very important. So they will write their forms of energy and add the sources as we see on this slide. Energy, which is the form, and the source. So maybe number 2, I can put chemical energy here, and the source could be any chemical that I know of, like acid, okay, or even the lime or lemon, or those are chemicals that we can talk about. You also have to engage students extensively on the mechanical energy as composed of potential and kinetic. You know, I've been talking about the fact that when they list the source of energy, they should also be able to tell you the forms of energy that can come out of that source. Or when they give you the forms, they should tell you the source from which that energy, is coming from. And so we know that mechanical energy is made up of potential and kinetic. And so some activities on your slide are meant to show students how mechanical energy can be potential and at the same time kinetic. You see a lady riding a bicycle and she paddles. So by raising her leg and paddling, you have mechanical energy. The leg goes up, is potential, and then drives down, kinetic, and the bicycle is also moving, kinetic, and all those things. In fact, it also starts from the fact that she has eaten some food. Okay, yeah, and all this we'll be looking at very soon. When you have a bow and arrow, the bow and arrow should have an elastic material, and so that elastic material holds the arrow, and once you stretch it, that is what we call elastic potential. You release and the bow would release the arrow, and so you see the arrow moving, and that is kinetic energy. A similar case can also be seen with the use of catapults. You see a man doing some weightlifting, people trying to do all sorts of things. These are evidence of the existence of mechanical energy consisting of potential and kinetic energy. Now, depending on the class you teach, you may treat the formulas for kinetic and potential energy, which we saw in our second lecture, source of energy and then the energy itself. So I know that in the DHS, they do simple calculations on kinetic energy and potential energy. So it is not out of place to help students to understand these concepts by way of knowing the formula, as you see on your slide. We said Ke, which is kinetic energy, is equal to the mass of the body multiplied by its velocity divided by 2, or half mass times the velocity squared. Students should also know that potential energy is calculated using the formula P equals mgh. We have defined the terms already. At this stage, you are not supposed to take students through derivation of these formulas. All you need to do is to let them know what each of the symbols in the formula represents. I believe we have some questions to put across for solutions. And so I would encourage you to write your questions down and send it to the various platforms, especially the virtual platforms of KNUST and Google platforms, so that the tutors in charge would help you to understand the problems that you face, or they will help you in solving the problems that you have. Now, these forms of energy, like we said, can again be classified into two. So depending on where you find yourself, the class that you find yourself, you might want to guide students to separate forms of energy into kinetic and potential energy, what we may also refer to as dynamic and potential energy. So in the last lecture, we saw that potential energy can come in the form of elastic potential, gravitational potential, chemical potential. These are, some forms of potential energy under potential energy itself. Kinetic energy can also have 8 forms. The forms may take light in transit, okay, so light or sound. When I talk, the sound that I make moves, and so that is to explain the fact that kinetic energy is the energy a body has because of its motion. So you may have your students do that classification. They should look at all the forms of energy available and then classify them under potential and kinetic forms of energy. So on your slide, you can see that I've made some efforts to classify the forms of energy into kinetic and potential. So mechanical is under kinetic, okay? The aspect of it is the kinetic itself, and that you have to understand, because the mechanical is made up of potential and kinetic. But if you take an aspect of it which is related to the movement of the body, we can still call it mechanical. We have electrical energy, we have radiant energy. So light is a form, heat is a form of radiant energy, and so on. Thermal energy, sound, these are all, under kinetic. Under potential, like I earlier on mentioned, you have chemical potential, gravitational potential, elastic potential, and nuclear potential. Because you see, under nuclear energy, like we said, uranium would disintegrate. So the energy is stored or kept in uranium, and when it undergoes radioactivity, then it will release radiations like alpha, beta, and gamma particles, and this is accompanied by large volumes of energy, which your students should know about. Now, in lecture 2, we also saw that these forms of energy, or even the sources, We can actually not create them and we cannot destroy them. Okay? This law came about as a result of an experiment conducted by Julius Robert Mayer. So we know we can't create energy and we can also not destroy, but we can change it from one form to another. And this is what we have always referred to as the law of conservation of energy. Your students must know that water that is running, or running water, if I should put it, or hydropower, can never get finished. We have mentioned that. You don't actually create it, and you can't destroy it, because you can only change from one form to another. The water cycle is even there, and you always have the water in there, the sun scorches on it, it evaporates, goes to the sky, some form of condensation will take place, and you have these clouds formed, and when they are heavy, so that the atmosphere cannot sustain, they fall as precipitates. So rainfall and other things. What we're simply saying is that we can't create energy and we cannot destroy it, but we can change it from one form to another. So the sun coming with heat, the heat may change into some light, the light may change into some other forms of energy depending on which gadget you are using. And this is very, very important in the learning of energy. So the law of conservation of energy, as we have stated, said the energy in the universe is constant. Energy can neither be created nor destroyed. It can be changed from one form to another. To demonstrate this, you need two rotor stands and clamps. You also need a pendulum bob and thread. You will need a long bar or rod. If all these things are not available in your school, then you may need any fixed points where you can hang any ball. And what we want to get is this: a bulb hanging at a fixed point and can be displaced. You displace it to a certain angle and you let go of it, and it goes up and down, a form of oscillatory motion. And so at a point in time, as we saw in the second lecture, you are likely to see the ball at a height. At another point, you see it down. Supposing we take this point as the starting point, you may see it there, it goes to the left, comes to the right, and so on and so forth. At the highest point, when we say highest point, it means the body has come to rest. So at the highest point, energy there will be potential energy. When it is falling, the potential energy will be changing to kinetic energy. Then it falls to where it started from. We say just before it hits the ground, all the potential energy would have been converted to kinetic energy. Then the process starts again. So the kinetic helps the ball to go up to the height again, and it hits the maximum point. And so in this system, we see potential changing to kinetic, potential changing to kinetic, and back, and so on. That is a demonstration of conservation of energy. Energy in that system is actually fixed. It cannot be created, it cannot be destroyed, but you can change it from one form to another. These are other ways by which you can explain this to your students. Now, The law of conservation of energy allows us to interpret how gadgets, especially electronic and electrical gadgets that we have in our homes, function. Okay? If you know the law of conservation of energy, then it will help you to understand the operating principles of various electrical and electronic gadgets in your homes. For instance, if I buy a bulb because I want to produce light in my home. If I buy television, then my aim will be to watch and listen to people on the TV. At the same time, if you are a bellboy of your school or bell girl of your school, you ring the bell and your interest is for the bell to create sound for students to either assemble or disperse. And so when we study the law of conservation of energy, we get to know that energy can change from one form to another, as we see in the various operations of the electrical and electronic gadgets that we have in our homes. Now, teaching this should be very interesting for you and your students. Why? Because these are practical things that you can do to get students to understand the concept properly. So, on your slide, you see an activity which says that you should guide students to make meaning out of these activities. The activities we have here are only 3, but your world of examples is unlimited. You have so many examples that you can cite. In the first diagram, you see a kettle, and you see a plug, and perhaps a socket somewhere. So invariably, this is just telling you that when you should plug this, into a socket, the kettle would heat your water for you. And so we are seeing that some electricity will now change to heat energy. In the second example, you see food here. Food is food. Yeah. Look at your faces. You are all laughing. Laugh. People have started licking their mouths. This is banana. We have orange. We have some. Looks like the thigh of chicken, and then some, tomato there. So this together can form a very delicious meal. This man on the bicycle has eaten, and that's how come he is riding the bicycle comfortably. The sun, as we see in the third diagram, is providing electricity for this household through the solar panels that we have on it. So these activities, if students are able to interpret these activities, including others that we cannot have on this slide, then they will be able to tell you how these gadgets or these activities are made possible by the supply of energy. And so guide students to state the law of conservation of energy before you do this. Now, once you have done that, it is also very important to guide students to conceptualize the guidelines for construction of transformation chain for energy, how energy will change from one form to the other, to maybe the last energy that you are interested in. And so we may guide our students or take them through switching on torchlight using dry cells, pounding fufu, switching on television, ringing of bell, riding bicycle, and all the other examples that I've given. And they will be able to realize how energy changes from one form to the other. In lecture 2, we saw that some of the guidelines include the fact that your students must know reasons for which they buy certain gadgets. Nobody will go and buy television and, bring it home, television to produce heat. Okay, you don't use television to warm your rooms. And so when you go and buy a TV, the purpose of it is to show you pictures that is light and also produce some sound which you hear. And so in carrying out energy transformation, the student must know the purpose for which that activity is being carried out. In that case, if it is a gadget, why that has been manufactured. So questions like, why do you buy things like bulb, television, electric heaters, or cars, etc., etc.? Students should be able to tell you answers to this or give answers to this. Then again, you should also find out from students how these gadgets that they have bought, okay, how they will make them work, or how they will work, or what will make them work. Yes, I think the latter one is, the best to talk about. What will make the bulb work, what will make the television work, what will make electric heaters work, and also cars to work, and so on and so forth. So I'm sure students may tell you television will need electricity to work, okay? A bulb may need a battery or electricity to work. The electric heaters will need electricity, cars will need fuel, and so on and so forth. So that becomes a principle upon which you may look at how the energy will change from one form. Because if I buy a bulb and I want to use the bulb, I must get electricity. So it means when I'm constructing my chain, the electricity must start the chain. Without electricity, the bulb will not work. So I should start by saying from electrical energy, then to what I'll get before maybe the final use. And sometimes it could even be from this form of energy that will make the thing work to what you are interested in. The third point, which is also a question, find out from students which form of energy comes between question 1 and 2. You are not going to tell your students or ask the questions in this form. You have laid out these two principles. The first one being the function of the gadget or the activity, and the second one being the form of energy that will help the gadget to work. So the third one, you are looking at an intermediary form of energy that will lead to the second one here. So that energy should come between the first and the last. And that is very, very important. For instance, if I take tungsten filament bulb, what you normally call the onion bulb, or sometimes you call it jelly bulb or whatever, you need electricity to make it work. So in that case, I may write electrical energy as my source. It's a form of energy, but it's a source from which this bulb may work. Then I know that that tungsten filament bulb contains an element called tungsten. The element will have to heat up. So it means that the electrical energy will first change to heat energy. Then finally I'll get my light. So light energy comes last year, and then we are saying that this, or the middle one, which is the if you like, the heat energy, is an intermediary form of energy which is seen between why you bought the bulb and what makes the bulb to work. Other examples could be cited, but basically we have these principles on the lesson 2 lesson, but it's still here because it's very important anytime you want to teach the transformation of energy. So as you see, said form of energy that will make the activity possible begins the chain. Form of energy that leads to the final activity, intermediary energy forms, or middle of chain. We also have why the activity is carried out, function of the gadget in that sense, and ends, that ends the chain. Now apart from this, all other forms of energy that comes after is regarded as a waste, and like we said in our lecture, you use plus to indicate. So in the example that we have provided on the board here, we also know that even when we are obtaining light from the bulb, we still get heat. So that heat that comes from the bulb is waste. And so you say plus heat energy. Remember, this heat energy here is not an intermediary. It is as a result of probably inefficiency on the part of the tungsten filament to produce large volumes of light that you are interested in. And so this is an animation of what we have just talked about. This is a dry cell. When connected to this bulb, this is a tungsten filament. This has to glow. When it glows, then you can have your light and the bulb. And so for this particular example here, I may have chemical energy in the cell changing to electrical energy. Then that electrical energy will change to the heat energy in the tungsten filament, and the heat will now change to light energy plus heat again. So for assignments, I would ask that you sit back and draw a concept map for teaching forms of energy. Not the entire thing. We are just looking at how to teach the forms of energy. Okay? So supposing I have a topic to be taught, and the topic is forms of energy. How would I go about it? What do I need to do for students to, understand the concept? As I started with, you can't make yourself a robot teacher. So don't look at what I have on my slide and go strictly by it. Sometimes it is during teaching that you get to know that this thing has to be said before this one will come. And so we normally would want to look at the faces of our students, find out what they are thinking through facial expressions and sometimes questions that we pose. to be able to know which step we have to move to, or whether to go back and look at some concepts that they have not learned. So as professional teachers in the making, we don't want you to be robots, because teaching is an art. The way you draw, okay, will differ from how I draw. The way you read things will differ from how I read. The way you perceive the learning of, the nature of the learning of your students will differ from, and that's why we have individual philosophies and beliefs. Based on this, every lesson you teach must reflect your philosophy and beliefs. That way, you will be able to design a better lesson for your students. Thank you very much for attending the lecture, and hope to see you in lesson. Please, a short announcement. Some of you have not submitted your assignment 1, and you are aware that the submission date has elapsed, and so I'm just taking this opportunity to remind you to submit the assignments, even though they are late. It's a better late than never. So submit them so that your tutors would have access to them and mark them for a good feedback. Enjoy the rest of the day. Bye.